Okay, buckle up. Here we go. Let's just jump right into this. Any questions along the way, please feel free to ask. Go ahead and mark your diagram. The givens are already written in there for you. We don't have to waste time doing that. Mark your diagram up. Everything marked up, ready to go. Okay, proof statement now. Look at the proof statement. TD congruent to RO. All right, in my mind, at least right now, I know how this proof's going to end. How? CPCTC. That's not happening, though, unless I prove what first? Congruent triangle. So we need to make a class decision right now. Which two triangles are we going to prove congruent? Again, prefer two triangles that have TD and RO in it. And now we come to a little point here where it's like, whoa, wait a second. Couldn't I prove the left and the right one congruent? Because that has TD and RO. Wait a second. I could also prove the top and the bottom one congruent because it also has TD and RO. Let's make a decision. Let's make it not, I don't want to say a smart decision, but an informed decision here. Easier decision. Which pair of triangles up there is a little bit easier for me probably to start out with? Proving congruent. The top and the bottom. Why? I already have a pair of angles and a pair of sides. So why don't we start with those two? All right, you got it. So we are going to try to prove these two triangles congruent to each other. Because you already have a pair of sides and a pair of angles. My proof, though, only has a pair of sides. So automatically, before we forget, what should we write in right now? The right angles are congruent. So angle TDI congruent to angle ROE. Right angles are congruent. I know some of you are probably thinking, what was he talking about all week? These are not bad at all. I've already have 2 out of 3. I have a pair of sides in the givens, and now I just proved a pair of angles. So all I need is one more pair, right? I'll let you look at it, talk about it. Sure. I'll give you guys about 1.5 minutes, 2 minutes to try to find another pair of sides or angles that maybe I could use. Full sides, please. Full sides or full angles. You cannot subtract 2 reflexives or add 2 reflexives to each other. That will never happen. You cannot add or subtract triangles together either. All right, let's come back together here. Let's come back. And it's okay to be honest today. How many groups are just plain stuck? Cannot find. Look at all those hands. Perfect. You know why I love seeing that? Because you're correct. You cannot find a third pair right now. They don't exist. So what's that mean? We're done? It's impossible? No. It does not mean that. But you are correct. There is no, right now in this point in the proof, there are no congruent sides or angles in those triangles. So what we need to do is get our attention off those two triangles. We'll come back to them. So now pay attention to two triangles you can prove congruent. Find two triangles up there you can prove congruent right now.
Oh, wait a minute, yeah. And then that's how your flexes work.
Okay, enough. Any group want to volunteer here and tell us which two triangles can be proved congruent? This group up front, go ahead. Which two triangles? Everyone see them, the big ones here. Not yet, though, because I only have two pairs of sides. What else do I need to put in before they're congruent? EI, congruent to EI, yes.
That does absolutely nothing.
Now you can tell me the two big pair are congruent. I like it. Good. So triangle TIE is now congruent to triangle, if I go TIE, REI, no, yes, REI. By side, side, side. And I understand some of you are now thinking, why are you doing this? We had to prove those other ones, the blue and the yellow one congruent. Why are you going on to a different pair? Here is why. Now that I have these two triangles congruent, aren't any corresponding angles or sides in these triangles now congruent? Here's the clincher. Here's where we put everything together. Here's your job in your group. Find a full pair of angles or sides in these two we just proved congruent and in the two we were stuck on. Find a full pair of angles or sides they both share. They're there. They're there. Full pair of angles or sides that they share.
It's TI and RE.
And then your side, like I said, it doesn't have to be so it could be angle
Ours too big. Ours too big. Ours too big.
We could two big triangles and then
Okay, here we go. Let's come back. Where are those full angles that are shared in both pairs of triangles? And I already gave it away. Yes, it's got to be a pair of angles here. Angle. Angle. IER. Does everyone look at angle IER? Everyone follow your letters? Does everyone see how it's in the big triangle and one of the triangles I'm trying to prove? That is also congruent to angle TIE. What makes them congruent? CPCTC. They're in the big pair I just proved. And that was the missing link. There is your third pair, everybody. That was our missing link. There's our third pair. So now we can say triangle TID is congruent to triangle TID REO. By which method now? I have two angles on a side. Just got to determine, is that side in between on this one? Nope. So it's going to be angle, angle, side. And then finishing this up with what we said at the very, very beginning. We knew this at the end was going to be CPCTC. How about that, huh? Get ready for that today. That darn third pair that gives us issues isn't going to be able to happen until we prove another pair of triangles congruent. Okay? All good so far. All right, let's keep grinding. Here we go. 1 congruent to 2. 3 congruent to 4. And we're trying to get QET and QEU congruent. Okay, as always, what do I already have? Did the givens give me anything? 1 pair of angles, yes. 3 and 4. 1 pair of angles gave me. Good. Anything you can do on your own before we start talking other stuff here? Anything you can do on your own, Aaron? QE congruent to itself, that gives me another pair of sides. These proofs make you feel good inside. You're like, oh, I'm moving, and then you just come to a screeching halt. There's a pair of sides, everybody. Okay, before we give up on those 2 triangles, anywhere else in those 2 triangles I can go. Just focus on those 2, please. Before we give up and focus on a new pair. Anything else in that pair you can find congruent. Don't tell me right angles. There's nothing about perpendicular here, so stop. How? What's I said? No. You don't have 2 congruent angles. 1 and 3 aren't congruent. What's up, Charlotte? Is that a full side in either one, though? See what I mean? You would need TE congruent to EU. See that? Okay. TU is congruent to TU, but it's not a full side in either triangle, so. Anybody find anything? We're stuck, right? Okay, that's okay to be stuck. Now we just focus our attention on another pair, maybe. Can you find another pair that's congruent then? Jacob, what's the other pair?
You can do QTB congruent to QUB.
The bigger ones, right? Everyone see the bigger one? The ones that are right on top of each other on the top and the bottom, QTB and QUB? Because I already have 2 pairs of angles. And where's the side going to come from? Reflexive side, which I can just put in the step 2, QB equal to QB. Yep. I haven't lost anybody yet. Again, the green and the blue one on my diagram can't be proven congruent. So I moved to a new pair, which were triangle QTB, congruent to triangle QTB, QUB. By what method? Angle, side, angle. And here's the tough part now. Because remember, we were 1 pair away in these 2 triangles. We were 1 pair away. So now you got to find it. Find a pair of sides or angles. Ready? Find a pair of sides or angles that are in the 2 triangles we just proved congruent and also in the 2 we need congruent. Go ahead. You guys got to do that on your own. Can you find a full pair of sides or angles that are in both? We don't know that, Violet.
Oh, angle 3, angle 4. Okay.
Okay, any group want to volunteer the missing link? Missing link, group in the corner. What do you have? What's the missing link that's going to connect it all? Side QT and side QU. Got it. That was our missing pair. QT congruent to QU, CPCTC. Now I have all three pairs. Now I can say triangle QET is congruent to triangle QEU. By what method? It doesn't look that intimidating when you look at the finished product, only 5 steps, right? But that third pair. Anything from you guys? All right, one more together, and then you got your assignment to roll on. All right. I didn't give you anything was congruent, but I gave you this piece of info that AC and BD bisect each other. What are you marking on your diagram if you know that? AC and BD bisect each other. What can be marked on my diagram? Let's hear from 7. What can be marked on my diagram? Yep. And separately, CG, yes, is congruent to GA. Nice. So let's put that right in the proof before we forget about it. DG congruent to GB. GC congruent to GA. Definition of a bisector. And look at what you just gave yourself right there. What did you just give yourself in step 2? 2 pairs of sides. In the triangles they're asking me to prove congruent. Don't give up. Don't give up yet. You may be able to prove those triangles are congruent right now. Also, I mentioned yesterday, strategy. You have 2 pairs of sides. You've narrowed it down to 2 methods. What are they? Side, or? Okay, so you know you're either focusing on proving DC congruent to AB somehow, or you're focusing on the angle in between the 2 sides, if I can prove them congruent. I don't think you want to give up too easily here. Don't give up too easily. Because you can prove these triangles congruent right now. I am not going to move on to a different pair. They can happen right now. Ready? Watch the magic. Some of you don't see it, and I understand that. Ready for the magic trick here today? Ready? Watch my magic trick here. What do I have here? Once I take that vertical line out, what do I have? Vertical angles. Okay, so yes, they can be proven congruent. That wasn't as great as last period, but. So angle DGC congruent to angle AGB. Vertical angles are congruent. And that gives me a pair of angles. Look at us, huh? Not bad. Oh, but there's a second part. Prove GE and GF are congruent. Can I just finish this in step 5 and say they're congruent by CPCTC? No, good, because they're not sides in these triangles we just proved congruent by side angle side. So it's not going to be CPCTC and I'm done. All right, so how do I get them congruent? Probably prove what first? Triangles that contain them. So I can say CPCTC at the end. Oh boy, we got a huge decision to make here. What 2 triangles? Because you could do, look, seems like I could do a bunch of combos here, right? Well, let me pick a combo and you tell me, and you boo this and tell me why it's an awful combo to pick. How about that one? Because that has G in it. And how about this one? Because it's got GF in it. Why are those probably not the ones to pick? The sides aren't congruent. You're left with nothing right now. All right, the sides aren't even congruent. All right, so how about instead of those two, I'll keep that first one I had, and why don't we do this one? Because I already have a pair of sides. Or you could do the unhighlighted ones too. Same thing. Can you get those congruent anyhow? Well, I already have a pair of sides. Anybody see anything else? And remember, you just proved the big dog's congruent, so you can use any of their corresponding parts to your advantage. Go ahead, talk it over your proof. You find the other two pair right now. Dig deep, find the other two pair. You have your pair of sides. Dig deep for the other pair. Any group want to volunteer a pair of sides or angles right now? Pair of sides or angles? Confident back there, ladies group? Go ahead, Naomi. Got it. Yep. Angle C and angle A are congruent because they are corresponding angles in the big triangles. So they're congruent by CP/CTC. That was the tougher pair, I thought. Does everyone see that, though? C and A are both in these two I've highlighted and also in the big ones we just proved. So they are congruent by CP/CTC. And I don't know, maybe this other next pair was the harder part. Kevin? Yeah, there are vertical angles there too. Those are vertical as well. I heard some arguments about them. Remember, vertical angles are formed by two intersecting lines, which they are. So angle FGC congruent to angle AGF. Vertical angles are congruent. And now, why are the triangles congruent? Did I write AGF, F? Yeah, we're good. Oh, that's an E? Yeah, there you go. That's an E, not a. There you go. Ooh, maybe. Okay. Why are the triangles congruent by what method? Angle, side angle, and then we finish this off with CP/CTC. Whew. Okay. Before you get going, because you have over 10 minutes to start, this is all a mixed bag of proofs that you're heading into now on your assignment. It's not going to be, I got stuck, so prove another pair. Not all of them are going to be like that. Okay, not all of them are going to be like that. It is a mixed bag. Call me over if you're stuck. Go ahead, let's get going.